Alright guys, this is Unit 5, Chemical Reactions. If you are honors, then this is actually Section 1, Conservation of Matter, because we did a lesson in class on how to read a chemical equation, which is what Section 1 is for notes for general. So if you're in general, this is your Section 2. If you're in honors, this is your Section 1 notes. So this whole section of notes is going to be on how to balance reactions in order to make sure that energy is not created or destroyed, or that matter is not created nor destroyed. You're just going to be writing these in your notebook, and then we should have a practice problem set for you as well that you should be doing at the end or partway through the video. You can start and be working through it. So, the law of conservation of matter or mass. This shouldn't be anything too crazy new. The law of conservation of matter says that matter cannot be created nor destroyed, it can only be changed. So what that means for us, and the significance of that, is that in a chemical reaction, whatever you start with has to still be there when you end. The number of atoms have to be the same at the beginning and the end. The type of atoms have to be the same at the beginning and the end. The only thing you're changing in a chemical reaction is which atoms are bonded to which. You're changing the chemical bonds, not the atoms themselves. So, what must go in, or what goes in, must come out. And we show this by what we say, by what we call balancing equations. So balancing equations is not the same thing as writing the correct formula. So if I tell you to write the equation for copper, or write the formula for copper 2 chloride, this isn't balancing. This is just writing the correct formula. Copper has a +2 charge. Chlorine has a -1 charge. Therefore, the formula would be CuCl2. This is still happening. So if you have ionic compounds, the charges need to add up to 0. This is not balancing an equation. This is just getting the correct formula. Before you can balance the equation, you have to have your formulas correct based off of their names. So you don't ever mess with the formulas after you have the correct formulas. We have to balance it in a different way, but you will not be changing these small numbers because those small numbers tell you in that molecule how many atoms of chlorine do we need to zero out the charge from the 1 copper. So, now let's say that we have our correct formulas. In this case, that would be everything in the black and the blue in this picture. So the balancing equations, you must first count the atoms present. So you already would have everything written in black and blue. That would already be on your paper. Already done. Then you can count the atoms. So we have, over here, 2 hydrogens. We have 2 oxygens. 2 hydrogens and 1 oxygen. Ooh, that's bad. We don't have enough oxygens there. So in order to get the oxygens to balance, so that we have the same number of oxygens on both sides of the arrows, we're going to be adding something called coefficients. So the coefficients tell you how many molecules of each thing we need. So in this case, we have H2. The number 2 tells us that I have 2 H2s. The number 2 here tells us I have 2 water molecules. And inside the water molecule, there are 2 hydrogens and 1 oxygen. So now that we have our coefficients out front, we now have 4 hydrogens there, 2 oxygens there, 4 hydrogens here, and 2 oxygens. So now we have the correct number of each element, which is the whole purpose of balancing. So remember, the subscripts are the small numbers that are written after the element symbol and placed slightly lower. So those would be your 2's. So this is hopefully review. This is from last unit in Unit 3, where we pointed out that the subscripts tell us how many of the hydrogen atoms or oxygen atoms we have. So there's that subscript that tells us we have 2 hydrogens. There's not a subscript there, so that represents 1 oxygen. Down here, we have 2 nitrogens. 1, 2. We have 4 hydrogens. And we have 3 oxygens. Okay, it's really important that you can count the number of atoms in a substance, because the whole basis of this is that we have the same number of atoms on the left side of the arrow and the right side of the arrow. If you count the atoms incorrectly, then it's going to be really hard to balance them out. So with the parentheses, let's practice doing this with the parentheses. Don't forget that the parentheses are essentially like a distributive property. So in this case, this 2 belongs to the oxygen atoms, and it belongs to the nitrogen atoms, but not to the calcium. So we only have one calcium here, but we have 2 times 1 gets me 2 nitrogens, and 2 times 3 gets me 6 oxygens. We had to distribute there. So same with the one over here. This 2 belongs to the phosphate, or so the phosphorus and the oxygen, but it doesn't distribute to the magnesium. It only distributes within the parentheses. So we've got 3 magnesium, 2 phosphorus, and 8 oxygen atoms there. So at this point, you should be able to do the top half of the worksheet, where you are just counting the number of atoms inside a molecule. So now that you've finished the top half of that worksheet, you can go ahead and we can start practicing with the coefficients. So the coefficients tell us, they tell you how many molecules you have. In this case, we have 3 molecules of calcium nitrate. So why is this not working properly? We have 3 molecules of calcium nitrate. So that means inside calcium nitrate, there were 3 calciums, 2 nitrogens, and 6 oxygens. But I have 3 of those. Therefore, 1 calcium. Therefore, I now have 3 calcium atoms. I have 6 nitrogen atoms, because I have 3 molecules, and inside each molecule there were 2. And I have 3 times 6 is 18 of the oxygen atoms. For the magnesium acetate, there was 1 magnesium, there were 4 carbons, there were 6 hydrogens, and there were 4 oxygens inside 1 molecule. But I don't have just 1 molecule, I have 5 molecules, so I need to multiply each of those by 5. So 5 magnesiums, 20 carbons, 30 hydrogens, and 20 oxygen atoms. So now that we can write a correct formula, and we know what products and reactants are, we know how to write a formula from a word equation, now we can go ahead and we can balance the equation. So remember that that chemical equations are like a recipe. So the recipe has to tell us what the reactants are and how much to mix together. So we've already learned how to write word equations, and that told us the first part. It told us what the reactants were, it told us what the products were. But now we're moving on to the how much. Okay, the how much is the new stuff. That is the balancing of the equation. So the first rule is that you need to have the correct chemical formulas for each compound. Once you have the correct chemical formulas, you do not touch the chemical formulas themselves. If you know you have magnesium chloride, you need to have the correct formula as MgCl2. Now that I have that correct formula, I'm not going to mess this up, because if I mess up these little subscripts numbers, then I'm changing what the actual compound is. I'm changing the substance, and you don't want to do that. So your first step is to write the correct formulas for each substance. So you're writing the word equations that we did yesterday. Then you are going to balance them. But you never want to start with the oxygens. Oxygens traditionally just get kind of weird. So don't start with the oxygens. Like, it's not going to be detrimental if you do, but it's going to take a lot longer. It wouldn't be wrong, it would just take you a lot longer to get to the correct answer. Your coefficients, your numbers out in front, always must be whole numbers. I can't have 1.5 molecules of magnesium chloride. I need to have 1 or 3. You can't have 1.5. So I'm going to have my unbalanced equation, which we already practiced how to get there. Then underneath my equation, I'm going to go through and I'm going to write out how many of each atom I have. So I will literally like go out and write this down until I feel really comfortable with balancing equations. So everything over here matches what is on the reactant side. Everything over here matches this product side. And it's just counting up the number of atoms. So we cannot change these small numbers, the subscripts in the equation. I can only change the numbers out in front. So what I like to do is I like to actually go through and I like to write this stuff here in pen. I write all of this in pen. And then I can only add the numbers out in front. You can't change the subscripts in there, okay? So when you balance the equations, we have the same number of carbons. Check, check. Good. We don't have the same number of hydrogens or oxygens, so we need to fix that. So in order to get the correct number of hydrogens, I need more hydrogens on my product side. So I'm going to put a number 2 out in front there. That gives us now 4 hydrogens, and that gives us 2 plus 4 oxygens. Okay, so now our hydrogens are check, check, but our oxygens are not. Okay, so now let's go through and change our oxygens. Okay, I've got 4 oxygens on the right side, but only 2 on the left. But if I put a 2 out front, that changes that to 4. Check, check. You might run into situations where you have to go and rebalance things. You can rebalance it however many times you need, but always check your answers and make sure that you have the same number of each atom on the left and the same number of each atom on the right. This is your final answer down here. If you knew the states of matter, you should also include those down there as well. So here's our next one. Again, I would write all of this stuff in pen on my paper, because once I have that down, once I know aluminum oxide is Al2O3, you cannot change those subscripts. Then your next step is to look at the number of each atom. So there's 2 aluminums and 3 oxygens on the left, 1 aluminum and 2 oxygens on the right. So that means that we need to have 2 aluminums over on the left. So I'm going to put a big 2 out front. Okay, check, check. Now here's a problem. I told you not to start with oxygens. How do I get these oxygens to equal the same thing? Now the issue is that I have to change both of them. So I can multiply this one by 2, and that's going to change this to 6, but that also changes your aluminums. Now we have 4 aluminums. Okay, so that's not good, but that's okay. Let's keep going. So now I've got 6 oxygens on the left. I want to have 6 on the right. Okay, so I've got 6 on the left, 6 on the right, but my issue now is that my aluminums don't balance. So let's fix the aluminums again. So I got to get this guy to 4, and now we have 4, 4, 6, 6. So do you see how I had to go back and I had already balanced the aluminums and then I had to go back and fix it? Sometimes that happens. It's not a big deal. You'll get to the correct answer, but sometimes that happens. If you continue working through a problem and you're working and working, and it is not balancing out, then your formulas are probably wrong. Okay, so I'm going to write that down so that anybody who actually isn't listening to the audio can actually see that. If it's not balancing, check your formulas, because your formulas are probably wrong. Check your formulas! Exclamation point! Okay, so now go ahead and go finish the rest of that balancing equations worksheet and be ready to practice this more tomorrow. At this point, you should feel comfortable writing chemical formulas. You should feel comfortable using the plus sign and the arrow in your chemical reaction. You should know what a product is, what a reactant is, and you should feel comfortable identifying the state of matter, especially if it's given to you. You should also understand why we balance reactions and how to do it. Now, you don't need to feel super confident on your ability to balance at this point, but you should understand the general process of it and get to the point where you feel like you just need a little more practice.